For the next few weeks, we're going to look at a different programming paradigm called object-oriented design. So far, we've looked at top-down design, and if you recall from Chapter 8, top-down design just created a hierarchy of tasks. And these tasks we put into a hierarchy chart. And then each of these items in the hierarchy chart can become a function. And we got the concept of functional abstraction way from the beginning of the semester, of stating the tasks but not going into the details until later, and then coding it later. Well, with App Inventor and with many other programs, there's a different programming paradigm, and it's called object-oriented programming. And instead of solving it by breaking your big program down into tasks, what you're going to do is you're going to break your program into objects. So here are some terms that you need to know for object-oriented programming. First of all, when you see objects, you're going to think of the nouns. What are the nouns that are in your problem set? Objects have then the data attached to it. So a noun could be, for example, a car. So you might have a car object, and the data attached to it could be its current speed. In functional or top-down design, speed would become a variable that was off on its own and grabbed when you need it. With object-oriented design, speed is attached to that object. So you can have 3 different cars, each with a different speed. And that's known as a property. The description of your object, I like to think of as adjectives in our grammar kind of comparison. And so the description of our objects, or the data that the objects contain, is attached to the objects, and we call those properties or fields. The behaviors, those tasks that we kind of broke things down into, they're still tasks. Things got to get done. But the tasks are also attached to the object. So when you move an object around, coming with it is all the extra stuff, all the data attached to the object, all the methods or the behaviors that that data is able to do. And tasks are normally verbs, so methods are verbs. Finally, one other thing that can happen to an object is an event can happen to an object. So when an event occurs, the programmer may decide, oh, that occurred. In fact, we call this process an event listener. And when the event happens, we call it a trigger. So when an event occurs, the programmer says, oh, this has occurred. Now let me respond to it by, writing some code for that event. Compared to procedural programming again is where we did the top-down design and we made subprograms or functions. Procedural programs would step through a sequence. Do step 1, do step 2. Of course, if there's decision, you're branching, but you always come back to the sequence. That was procedural program, what we've covered so far. With object-oriented programming and event-driven programming, you don't know what's going to happen first. It all depends on what events, and events depend on the user. So it's not just step 1, step 2, step 3. One other concept with an object is in order to create the objects, you have to have the blueprint. So the code you write to create objects, we call a class. A class is the blueprint for an object. It contains all the directions that describe a particular object, all the directions on what events it can respond to, and all the directions on the methods or the actions it can do. So for an example, a race car application, you will write one car class, but you can have many cars in this race car application. So you use that blueprint to duplicate, just like you would for a house, for example. You can use the same blueprint to build many houses. You can write one class and create many cars. Now it's not a loop. Okay? So it's not like you're re-looping through it. So the class is your blueprint. Each different car that you create is an instance. That's the object. The class is the blueprint. The actual object is an instance of the class. Okay, so let's look at what we did in App Inventor with Hello Per. You created instances of objects when you dragged, say, the label or the button from the palette to the viewer. App Inventor is calling those objects components. Okay, so here are 3 components that you use. They are actually objects. You did not write the code, but you are very aware that there is code somewhere written for sound. I like that I don't have to write the code. All I have to do is use that class as a blueprint to create my own sound object. What makes that distinct? Well, in this example, I'm looking at the button. What makes that distinct is the properties. Recall setting the properties, recall setting the image, kitty.ping, and that makes this a distinct button compared to all the other buttons there could be in the world. In the blocks editor, clicking on button 1 shows me the properties and events I could use while coding. Let's talk a little bit more about that button 1 object that you added to Hello Per. So this is what you may see in the blocks editor. Recall that you had a My Blocks, and there is your button 1 object. Now when you click on the button 1 object, the blocks editor is showing you, in this example, some of the events that you can respond to for this particular button 1 object. So I believe that you did respond to the click event. So when button 1 is clicked, whatever blocks or whatever instructions you put right here will be executed. Now notice that there are 4 different events that this button could respond to. You didn't have to respond to everything, okay? So you did not add any logic to the Got Focus. It's possible for you to write it, but not every application needs an event procedure or an event handler for every event that could happen. You, the coder, decide, oh, I'm just going to use the button click event, for example. So these events exist, but you don't have to add logic to it. When you end up adding logic to it, we will call that an event handler. It's going to handle the button click event. Okay, now let's look at the sound component you added. So the object ended up being called Sound1, and you set the data for it. And so when you set the data for it over in the properties, that's a part of the object. That data is a part of the Sound1 object. And so you set the minimum interval and the source. And some of the methods, what are some of the tasks it could do? That's what methods mean. So back over to the block editor, some of the methods that a sound could do. It could pause, it could play, it could resume, it could stop, it could vibrate. Each of these methods end up becoming a function that you write, or in this case, a function that somebody wrote in some class called sound. So each method, if you're going to create your own classes, will end up becoming a function. And then when you get to that part where you're writing the function, say, for the play, then you do apply the top-down design concepts we introduced earlier. So here is an example of what you did when you clicked on button 1. So this is the button 1 click event handler. And 2 things happened. If you recall, you played the sound and then there was a vibration. Now this value right here we call a parameter or an argument. I didn't put it in this slide, but we also call it an argument. And if you go on in computer science, I'll be more specific on the difference between a parameter and an argument. But this argument is the input to that method. So that method will vibrate. Well, how long? Well, it depends on the value in that argument. So what do you think is the most common event to handle in a GUI application? Hope you've heard of the acronym GUI. That stands for Graphical User Interface, which is mostly what we do anymore in programming. I would say it's probably clicking on a button. I hope you agree with me, because that's what users are used to seeing as, oh, if I do click on this, something should happen. So usually when we want something, an event to be triggered, we'll add a button and add a click event handler for that button. Now let's take a look at this. So here's my question to you. Do you think this is a method or an event handler or a property? I think it's probably an event handler. Okay, so when you started shaking your phone, an event was happening. And so then you added some commands or some instructions. What do you want to do when the phone is shaking? So that shaking is an event handler. I think what you wanted to do was, the sound played. Well, the next application we're going to work on is called No Texting While Driving. And in this application, texting is a component that you're going to add. So they created a class called texting. And in this class called texting, you will have properties, data, for example, that a text will have associated with it. And you will have events that you will handle when a text comes in, for example. And you will have methods or maybe actions that you can do. In this application, you have a series of labels. Now this time the author decided I'm not going to just keep the generic labels, since we have two different labels that we're writing code to. Naming them label 1 and label 2 can get confusing. Which label holds the response, label 1 or label 2? So in the properties panel, it's possible to rename every object. By default, it's the component name and then some number that's appended to it. But when you're coding to it and you've got multiple types of the same type of component, it makes sense to rename the component. So you're going to be getting ready to send a text message out, and by default this is going to be the text message you'll send out. But you have a text box here, and in this text box you can change this message. So you can key in something here, click this button which causes an event to happen, and that will take the data here and then make it up here. That will be what you'll be texting out. In addition, you're going to have some non-visible components like you did before. Before you had a sound component, which is not something you see in the screen. Here you're going to have a tiny database, a texting object, and a text-to-speech object. Let's look at your texting object. You will have an event handler, and that event handler triggers when a message is received. So you're driving, you receive a message, an event occurs. What do you want to do? And that's what you're going to put right in here. What do you want to do when you receive a message? Or what do you want the program to do? So a method of the texting object is to send a message. So maybe you can just send your default message to them. Okay? And here are some of the properties of this texting object. So a texting object could have Google Voice enabled. A texting object has the message that you're going to text, and a texting object has a phone number. It looks like it also has receiving enabled. Okay, once again we're going to look at arguments, and arguments are just the input into your function. Now we may not even know what code it is. I don't know if you remember me using the term black box. But input is given to the function. A function could also be a method or an event handler. So an argument can go to a method, a function, and an event handler. It's just input that the function receives. Then the function, the statements in the function do its stuff, and out comes the output, or what you want to happen. So in some coding languages, which the CS Illustrator is referring to, your argument will be inside parentheses. So if you had an argument called sum, if you had a function called sum, you might do something like that. And so I'm assuming sum's going to add together. That's a good name. And so it would take these two arguments, probably sum them together, and the output would be 6. But the next time you execute sum, maybe you need to sum 2, 4, 6. Okay, so it's a different set of arguments, and So this might output, what, 12, okay? So here are your arguments. In many programming languages, you got your function name when you make a call to the function, and the arguments are in parentheses. In App Inventor, we're not using text like this to write our program. We're using blocks. So an argument in App Inventor will be attached to a block. And for example, the message received event receives an argument of the text in that message and also the phone number. Here is an example of an argument in an event procedure. So this event happened. Hey, you just got a text. Okay. So, well, what inputs do you have for me? Well, here's the number, and here's the message. That's the inputs to this message received. Then you can take those inputs and do different things, okay? So those then act like, kind of like variables in a way, with data that you can do stuff with. In text while driving, you will also do something called concatenation. The author referred to it. Concatenation may be a new word to you. It just means join together. So in this example, I have 4 pieces of information, and you're going to join them together to create one piece of information. So I have this, just this text, SMS text received from. That's just text, okay? But then I have a variable, the number. Hey, so if this person just called me, for example, that number just called me. And then I have more text. This message is received, and then this argument, remember that's the argument, is used, okay, as the 4th part of what I'm joining together. Okay, so what's happening is you're going to have a text-to-speech object, and there's a speak method, and what it's going to speak is one thing. That's the joining of these 4. So it's going to speak SMX text received from 309-555-5454. The message is, I will pick up Riley. That is concatenation. Also, in this example, if you don't save your data, you lose your data when the program stops. And so the data that you will be saving is you're changing your default message. You want a different default message to be sent out, or when you're driving and a text is sent out because of this application. So to persist that data, you're going to create, you're going to add another object called TinyDB, and DB stands for database, and you will be able to store small pieces of data in that database. Another alternative that you can do on some operating systems is you can persist your data by saving a text file. Now TinyDB, is a class. You create an instance of this class called the TinyDB1 object. That TinyDB has 2 methods. Well, you can save it, right? Or you can open it. You can get it. Store value and get value. Well, the first time you execute the application, there's nothing yet in the TinyDB. So you will be adding an if structure to make the decision whether or not, when you get the value from the TinyDB, if the length of the response is 0, that length means how many characters are in that response you just brought back, then you know that you're just going to use the default value from the original application. So here it is. Okay, so if the length of the response is more than 0, that means that there was something saved in the TinyDB, and that's the text that you're going to use. So you're going to take that, what was in the TinyDB, it's stored in this value response, and you're going to assign it to response label.text. Okay? This is known as a single alternative if. So if this is true, there's one action. There's no else part. Now down here you'll notice that there's an else part. So we'll call this dual alternative. There's 2 possibilities. So This is a kind of a silly condition. If some random number is equal to 1, that's a silly condition, but the purpose from the author was to show dual alternative. Then you're going to call this one if it is one, else you'll call this phone number. Okay, so there's two possibilities. Now, in life, there is a possibility of many, right? So if I go to an ATM, there's more than two possibilities. I might hit withdraw, I might hit deposit, I might hit inquiry, I might hit transfer. There's 4 possibilities right there. So if you have more than 2 possibilities, and you're going to be using if statements, what you got to do is you got to start putting an if inside of an if. Okay, so in this case I have 3 possibilities. I want to call this number or this number or this number. So the then part of the first if is my first possibility. The else part is the second if. And then you get your other 2 possibilities in the then part and the else part of that second if. So if you have 3 alternatives, note that you have to have 2 ifs. Okay, now look, I have 4 alternatives here. Okay, so alternative 1 is in the then part of the first if. The else part of the first if is another if. Alternative 2 is the then part of the second if. The else part of the second if is another if. Then finally alternative 3 and 4 go right here. So if you have 4 alternatives, there are 3 ifs if you're nesting. If you have 10 alternatives, you've got to nest 9 ifs. That gets kind of hard to do. And the last slide here just shows you the flow chart of your Text While Driving app, because I asked you to make a little modification. Actually, it's just the flow chart of the message received event. So the message received event is going to get 2 arguments, the number who just called you and the message text. And what you're going to do is you're going to make a decision. Okay, so I'm pretending this is my mom's phone number. Is this my mom's phone number? Then I'm going to customize the message that's going to be sent back to her. Hi Mom, I am driving, but I'll text you back soon. Okay, so this is that then part of the if, because I have 3 possibilities. Okay, so the then part of the if is my first possibility. Now this is the else part. Now the then part is when this condition is true. The else part is when this condition is false. So in the else part of this if, I'm going to check on my second possibility. So if my second possibility, it's my hubby, if that's true, I'll execute the then part of this if, in which I'll say, sweetie, I am driving, we'll get back to you soon, XXOO, okay? And then, so that's my second possibility is in the then part of the second if, and then my third possibility goes into the else part of my second if, okay? So this just means end if, and this means the end of this if, okay? See, this is nested inside of this if. And I think with a flow chart you can see it's nested inside of this if. And when I've made a decision what my text will be based on this nested if, then I'll go ahead and I'll execute the send message method of the texting one object. And that concludes my message received event handler.